Ladies and gentlemen, welcome to Fujitsu High Performance Computing website. When I prepared this presentation, I thought maybe you might have the question, high performance computing, what's for? I thought, okay, maybe we could talk about astrophysics and neutrino research, but it's so far away from human-centric, which is our message today, that okay, forget it. At the opposite, blast technology, genomic, we are touching real human beings, but it's so specific. So I thought, okay, what to do? Let's try to find a down-to-earth example. And this is what I prepared for you. A real example of what we do today. Let's move to the Pacific Ocean. This is eastern coast of Japan, a place where we have a lot of earthquakes, and we have a lot of electronic sensors everywhere able to detect an earthquake. When we detect this, it takes just a few seconds to know an earthquake is here, and we have a big wave coming soon. And we just have a few hours. If you use a normal computer, a few hours means, look, you will not get anything, you will not be ready. There is nothing you can do but wait and rain. However, when you use an HPC solution, you use these sensors information as the input data set for your numerical model. And you can think about a simulation where you can modelize in 3D the wave which is coming. It's not bad. If you do it quickly, you can even, before the wave reach the coast, predict it, because you know the energy of the wave, the speed of the wave. When you reach the coast, you can predict where the water is going from. Good. So you can start to put the alarm signals everywhere and think about using this information. You can go even further. If your computer is fast enough, you can connect your supercomputer to other database where you know where the buildings are, where the people are, and you start to organize things before the wave reaches the coast. For example, you can control the traffic lights and tell the people here, use this way to exit, while on the opposite side, use this way for firemen, for the ambulance. You can also think that you can connect this computer to hospital, and you find that we have 100 beds free here, or we have only 10 here, or we have some beds here. We have a surgeon here able to repair normal injuries. We have a surgeon here able to repair the deep injury. So you can start to organize everything within these few hours you have to save life. This is a true HPC example. So I will stop here. Just go on the web. Look for this. You will find the example. You will find the details. So now let's go back to you, end user, and people using HPC. We have 3 questions in mind always. When you need to install and deploy an HPC solution, the first question you have is, okay, I have my budget, and how much compute power do I get for this budget? And even if I get enough compute power, because my computer room is there for 20 years, I will not push the walls, no way. I have to find a way to put everything inside this computer room. And even if I can put my new solution, HPC solution, in this room, how to cool it down? Because computers are using more and more energy. So, 3 important questions to try to answer together. But let's do some joking first. To build a supercomputer, we need a processor. So, quite simple. We build Spark processor. This is Fujitsu proprietary technology, and this is what you will find in the K machines in Kobe in Japan, which is one of the largest supercomputers on Earth. It's very specific. It's focusing on national projects in Japan and running a lot of applications. At the opposite side, we have also the Xeon from Intel. Xeon Line. This is so popular processor. No need to explain to you what is a Xeon processor. We all know what is a Xeon processor. We all know about the EV bridge, standard bridge, as well, whatever. So this is very stable technology we can rely on. And we have also something interesting coming soon, the night landing. I cannot disclose too many things about the night landing, and my Intel colleagues are there, so they know more than me, eventually. But some of you already raised the question how difficult it is to use this night landing beast. So I would like to briefly give you two examples. The first one, what is the core of the night landing? It's Atom technology. So I am running a laptop with Linux on this laptop, and the core I'm using is Atom. So everything running on my laptop is running straight out of the box on the night landing. It's the same board. So where the power is coming from? From AVX 512, which is a vector unit you will find attached to each core. So in terms of application portability, everything will run on this. In terms of performance, if your application is already virtualized or ready to be virtualized, what we call the code vandalization, you will get performance. And in fact, well, I am an old field. I started to punch holes in paper cards in 1975, my first computer. And I saw a lot of things. And during the 90s, I spent a lot of time working on the vector processor. At this time, we had the Cray C90, we had the Fujitsu VPP, we had the SX from NEC, and vectorization was important. And I'm very pleased to see that vectorization is back to the future, which is interesting. I have my processor, let's build a Fujitsu computer with this. Again, we start with the Spark. We build the DFX100. Very ultra high-end machine. And I would say a bit expensive as well, but tell you that. It's so specific, made in Japan, and it's handmade, I can tell you. On the opposite side, the Premier chip. 6400 and the 6xxx for the night landing. And this is really the commodity. This is something which is built either in Japan or in Germany. We have a factory in Germany where we can manufacture everything. And we ship worldwide from Germany. So, easy to decide for you which way you want to go. Now, let's try to answer to the question, how many power will I get and how much electricity I need? Let's go first on the Primergy side. Primergy, the Xeon processor, stable, 1 rack 42U, I can put 80 compute nodes. The power is roughly 96 teraflops there, and I will need 34 kilowatt for this.